and welcome to another computer upgrade video. This machine is a couple of years old, and we're replacing we'll be videoing replacing the stock cooler with a high-end air cooler. Right now it's got the Intel stock fan, which is pretty small by comparison these days. This machine originally had came with a water cooler, which, as far as I can tell, the pump has failed because it's not circulating like it's supposed to, and the temperature goes up to the point where it goes into the red just at an idle. So I decided, in lieu of another water cooling system, I'm just going to get a high flow air cooled system for it. This machine's in a pretty dirty environment, and it's been in twice now to get completely gutted and cleaned and refitted. And so I want something that's going to run in adverse conditions when there's a lot of dust and dirt and airflow in the cooling system. I wanted something that's a little higher end. The Intel one works fine if the system stays clean, but if it gets a lot of dust and stuff built up in the fins, it starts to lose efficiency and it becomes inadequate fairly quickly. So let's get started. I'll go through the procedure as best I can. Thank you. Okay, this is a good close look at the air cooler. I chose a Scythe Mugen 3 primarily because of cost and efficiency. We didn't want to spend a whole awful lot on this customer's machine, but I wanted something that was kind of kick-ass, and this looks like it's going to be kind of kick-ass. We've got a lot of heat pipes, so fairly robust heatsink assembly. So it only comes with one 120mm fan, but that combined with the exhaust fan from the case should do pretty adequately. I've used a Scythe product in the past on another build, and it was a low profile build and kind of annoying to install, but as you're working underneath the heatsink with your fingers. But this one should be pretty straightforward, and hopefully give the machine lots and lots of airflow to work even when it starts to get dirty. Alright, let's have a look at the hardware assembly. Okay, so this little beastie is supposed to work with Intel 775, 1155, 1156, and 1366 sockets, as well as AMD AM2, AM3, and AM3 Plus. So we've got a multitude of hardware options here. This appears to be the back plate. It's made of steel, which is a good thing because a lot of them are made of plastic, and they allow a little bit of flex and maybe not hold things as tight as they should to the CPU. Also, plastic still prone to breaking under a lot of stress. It gets brittle over time and snaps, and suddenly your heatsink's not affixed properly to the CPU anymore. These guys appear to be the brackets for holding the fan onto the cooler. Not my first choice. I would prefer screws, but I guess if these work, spring steel, so it should be fairly resilient. And then we have our front brackets. I believe these are for the AM3 setup, and these ones would be the ones for the Intel. I can flip it over here. So you bracket into the holes in the motherboard. And we have screws and heatsink compound and a big 80mm fan. I like that they coated the wires with the braided coating, and it's in black so that it kind of gives it a dressy look for the inside of the system. Okay, our first step is to install the CPU, the brackets onto the cooler block itself. We're going to use this set of brackets for the 1156 board that we're putting it in. So I flip the cooler over, and note that there are threaded holes on the corners. This is a raised block. Also, should be noted, if you're putting in one of these new, they do have a piece of tape protecting the polished surface that contacts the CPU. You want to make sure that you don't leave that on. Number one, when you install the CPU, and we've got to put the brackets on, which means I got to kind of peel off the corner of it, or maybe just remove it entirely, and just be careful as I'm doing this. Ooh, nice shiny surface. Look, I can see myself. But we want to make sure we get this bracketed in there correctly. Referencing the instructions, it looks like the brackets go on this way, kind of that way, so that they're that way, because if you put them on that way, it's not going to fit. I did that once, not pretty. So yes, we have to put the brackets on that way with the tabs down. Yes. Okay, I'll be back in a moment. Well, I got our brackets installed. Just as a note, two of the kit splice 4 little panhead screws to mount these. 2 of them are a little difficult to thread in, so hopefully we won't run into a problem there. I got them seated, but I had to use a little bigger screwdriver than what I normally use. And the trick with these things is to make sure that they're all square, because if any of the tabs are bent, it puts uneven pressure on the CPU socket, and could affect the cooling. Okay, so we're ready to continue. Let's get the machine back up on the bench and pull the existing cooler. Okay, the next step is to remove the stock Intel cooler from the board. Let me unplug the power plug to it. Note that these are all 4-pin plugs. This is what Intel's new standard is for cooling. It allows the motherboard to dynamically adjust the RPM of the fan to based on CPU load and heat and all that. If you've never removed one of these before, there's a trick to it. They have 4 fixing points, and they snap down into place. Not a big fan of that, but to release them, you grab your small flathead screwdriver, and there's a little notch in the top of these things. I don't know if you can see that, but give them a 1/4 turn to the right, I guess that would be, and that puts them into release mode. And then you grab the little tab with your fingers somehow, you can get in around the heat sinks and pull them up, and it unlocks the tab so that the little plastic fork things can come out of the board. And then, in theory, sorry for the poor light, guys, in theory this should just pull right off the board, like that, revealing the CPU. I don't know if you can see that. Let me switch the camera to macro mode. Okay, there's the little push pin things. It's basically just a shaped fork, and when you push the pin down, the black pin in the center spreads those things apart in the holes and prevents it from coming out. At least that's the theory. In actual practice, sometimes they do come out, and not a good thing when that happens. Okay.